Jared Sperry. There we go. Okay, perfect. All right. Jared has been with the GIT group, Michael Baker, since 2003. He started with the company out of the Alexandria, Virginia office, where he first started using FME to perform database replication in 2006. He continued to leverage FME's processing capabilities for various solutions and attended the Safe Software FME User Conference in 2007 and 2009. In 2009, he moved back home to Western PA and has continued to educate Baker personnel on the capabilities of FME for LiDAR, BIM, GIS, and other data sets. He is now heavily involved in the federal government's plans to secure the southwestern border and uses FME to regularly produce monthly metrics reports on tactical infrastructure inventory.
Thank you.
Yeah, I'm not sure. Does this work in now?
Yes, just left and right.
Okay, yeah, so that'll work.
Left and right on that? No, okay.
Thank you.
So today I'm just going to talk a little bit about FME's capabilities to produce statistics. So I know a lot of these discussions and everything that we do is very spatial. I work a lot with the federal government, a lot of auditors, a lot of contract people. They're not too spatial, so we have to take our spatial data, turn it into something they're used to, like an Excel spreadsheet or a chart or any kind of report like that. So just kind of reiterate this, I actually put this together before the bio thing was written, so a lot of duplicated effort on there. I included the product owner thing. It's kind of a new, the group I'm in, we do a lot of web development, application development within Michael Baker, so we're using these buzzwords like agile and product owner and scrum and all these things, and I threw the product owner in there because it's relatively new, but I think it's applicable because what we're doing as a GIS industry is that we're gathering requirements from these people who may not be spatially oriented, and we're taking those requirements and we're generating these products for them to help communicate what it is they're trying to say. And that's really what being a product owner is all about, is being able to take those requirements and turn them into something tangible that you can give back to someone and improve that communication. A little bit about FME, if you don't know what it is, it's the Swiss Army knife for your data. That's a company line that they throw out there. It's a spatial transformation tool. So translating data from CAD to GIS to other formats, that's its primary bread and butter. He stepped away, but I was going to say for the folks at Blue Marble, it's job security, because you're constantly changing data formats, you're manipulating the data. FME doesn't have a lot of metadata type support, so it's taking the data and massaging it and doing different things with it and getting a different kind of output. Some of the more common tasks associated with FME is, like I said, converting your spatial formats, GIS to CAD, so on. If you have a data streaming service, anything that's got coordinate information in it that you want to make spatial, you can ingest that data, you can manipulate those coordinates, put them in line, and create spatial data from that service. There are certain ways you can get around having to maybe invest in software, such as a Pathfinder type software to extract Trimble data. So again, it's spatial data, it has coordinate information. If you know what you're doing, you can essentially bypass some things like that and start creating GIS data or shapefile data from that. And then the other bullet points there, the schema conversion. We did a lot with FME using it to convert production type schema databases to delivery schema. If we have domain tables, lookup tables, things of that nature that we have to convert in line for delivery, then we would use it for that. Then of course data integration. If you have people providing you data from different sources and you have a master database, it's taking all of those independent data sources and meshing them together. So here, what if we don't need spatial? So this is my question, guys. So this is my government auditor, right? So we work with Border Patrol. They've been undergoing about a 2-year audit of their processes, and some of the questions come out of that are, I want a data dictionary. They have no idea what they're talking about. They don't know what they want. So how do you get an auditor off your back? You give them an XML dump in your database. It's got 200 feature classes, right? So it keeps them occupied for a while. They're going to have some questions, but they're not spatial. They don't know what they want, but they like maps. They like maps. They like reports. They send shape files with just an SHP, right? There's no DBF, there's no SHX, they don't know what they're doing. Okay, so these are the people that I'm targeting right now, the people that are non-spatial, but they want to see the data in a different way. And I'm just going to talk about two high-level points about non-spatial use of FME. Talk about QC, I'm going to talk about metrics. QC is kind of glossed over a little bit, but just some key points in there for you to keep in mind. Data QC is common. Getting back to that idea, if you have multiple upload points, people compiling data externally that you want to have uploaded into a master database. Ideally, they're all following your data dictionary and your data collection guidelines, but that may not be the case. You might want to create some inline processes of data QC with FME that are part of that upload process where they could upload their data to you. You could run it internally through an FME workbench on a local license. And you can not only validate that data for QC errors, but if it passes, you can upload it at the same time. So just going to go over a few points about things to consider when using FME as a QC tool. Obviously, when you're doing QC, you have to have rules, right? So using FME to create rules can be done in a few different ways. What we've done is very elementary in that we know what rules we want to validate, so we're basically creating processes along that workflow to check to see if there's any violations of those rules. And this is a pretty standard layout of FME. The workbench, it's very model builder type environment. But you can see here what I'm doing is just, like in this one, for example, we have lookup tables, we have spatial tables, and we want to see if there's a direct correlation of all the lookup records that should match to a spatial record. Easiest way to do that is a table join. So in ArcGIS, you perform the join. Anything that fails to join, you see it's not connected, so that's an error. We're basically capturing all of those in here. So these are our joins. Anything that's successful, I don't really care about. I'm not going to move it on the process. Anything that fails. So these two ports here are basically telling me those are source features that don't have a joining record, or those are join features that don't have a spatial record. And so we're catching those, and we're creating error messages at that point to say, this failed, this record in the lookup table doesn't have a corresponding spatial record, or vice versa, so on and so forth. Another way to organize these kind of things in FME is you can create what's called custom transformers. These are the green ones. And these are they're useful if you have a lot of error messages. So if you have a very complex database and you have a lot of error checks to do, you can see, just to kind of give you an idea of scale, all right, this is one transformer, it's got some inputs to it. These are one transformer here. These are your base set of options, right? So if I have 30 of those, you can kind of get an idea of how your workspace is gonna grow. The custom transformers make it easy to manage these, where you can take all of these checks and condense them into one where if you go into their properties, you can see the details and you can see the full layout of your workflow and how that data is being processed, but in your canvas, you can organize them with your custom transformer so you don't have all that stuff to manage on your display. There's some different functionalities available with your custom transformers. They're kind of, if you're used to writing Python or any kind of code, you can work with the looping. They have looping capabilities. You can also share those like modules in your code. You can share those custom transformers if it's some kind of QC process that you think is applicable to other data sets. And of course, organization, which I just went over. Now the error messaging. So I said we're creating messages for all of our errors, right? So I've got a lot of inputs here. I've got a lot of checks, lines going everywhere. That's very FME. And of course, if you really wanted to take the time, you could create elbows and make it all nice, but nobody's got time for that. These are error messages in my process. So you can kind of see how, if you're creating a lot of unique error messages, you can see how your canvas is going to grow based on the number of transformers you have. And the error messages that you create, whether you choose to check everything at once and say this is all checking for one error message, this error message is going to be very generic, right? It's going to say your features have no name, right? They all have a name field, it's blank. These are all the ones that have a blank name field that applies to everything. Whereas up at the top, you have very specific error message that pertain to one feature class or possible 2 feature classes if it's a join. But you get an idea of how the error messages that you identify during your requirements gathering of identifying your process, that's going to dictate how complex your workspace is going to be in terms of your transformer management here. Just an example of how we create our error messages, we're using a very basic string concatenator. So it's creating an attribute and I'm giving it a value. And so every feature that comes into this transformer here, which would be over here on the right in the green box, every feature that passes all of these qualifications that goes in here is going to have this field created, error, with this message. And that's how we're creating our error messages. So your input feature classes, your shapefiles, your spatial layers, you're going to have your database schema. It's going to have a lot of fields, right? Your output, if you're creating an error report, it's probably not going to have any of that information. You're going to strip all of it out because all you care about is this. You care about telling, now in this case in QC, your input users are most likely spatial, so you could go either way. But if you're dealing with someone who just wants a report on what your data looks like, they want something non-spatial. So we're giving them back something like this. So we're creating a text file output. This is some of the idiosyncrasies of a text file. In order to create a header, I had to basically create dummy data. And then, so the first 3 rows there, I just created 3 records in the output. And I created, I hard-coded the values for those to create the header. And then everything starting at 1, all those object IDs are everything that came out of this process and fed into the output. So it's identifying all of the object IDs in my input that had an error. It's identifying the source feature class, the type of check, because I had different spatial or attribute checks. And then these, of course, are all of our error messages that we created. So a lot of repetition in there. Object ID 1 in my SLOMAR feature class is full of errors. So whether you choose to do that independently by reporting each error, or whether you choose to create some kind of combination process in your workspace that takes SLOMAR feature 1 and then puts all the errors together with it, that's up to you. That's something you can consider. And this is a friendly format. It's bar delimited. That allows us to, if we have commas or something in our error messages, then hopefully the end user is able to parse this back out. But it's very basic. It's a text file. It can be disseminated, imported into Excel, and it's very friendly for these non-spatial users. And of course, because maybe we want to see the output, it's useful for us to have something to drop into a GIS and see where the errors are. So spatial is always an option for us. So because you're using FME, you have a whole host of possible output feature types of GIS feature types. You can always write these results back out to a shapefile, the geodatabase, and then you have a spatial component that represents all of those tabular records. Now, for metrics. Typically, metrics reporting with GIS can be a bit cumbersome. It may require a lot of multi-step summary tables that you got to compile. You got to dump out to a DBF, maybe import into Excel, do all your massaging. Well, FME gives you the ability to do all of that stuff inline through FME and create nothing but your output. So instead of having your out folder with 30 different summary tables that are tracking 25 different statistics that you have to merge back together, you're doing all of that in line with FME, and all you're creating is that output Excel file. This chart here that's shown, I grabbed this from, I think it's the current FME release. I've never used charts in FME. I'm not sure what the full capabilities are there, but I'm pretty Excel savvy, so I'm dumping everything out and running my pivot tables in there, and that's how I'm reporting. But on the government side, they do all their charts and stuff. They can do whatever they want. Similar to how you would process this data using ArcGIS or some other platform, you have to know how to categorize your data so you can generate metrics on it. So in ArcGIS, you might have 5 fields that have your key fields, your stats fields. You want the min, the max, you're calculating mileages, minimum coordinates, maximum coordinates, those kind of things. You're using tools like your summary stats tool in our toolbox, and you're using those key fields to generate the output. You got to do the same thing in FME. It's just a different. It's done slightly differently. So in here, yeah, it's on the next one. In here, we're categorizing our data. We're trying to figure out what it is we want to analyze and how to organize those attributes in a way that we can use the built-in functions of FME to generate metrics on those combinations. This is an example, this little section here, I'm taking data that was in a Trimble file, a JXL, and I'm taking that data that's created, so if you can kind of think spatially with me, that data is created vertically. You're capturing a point, you're going to the next point, the next point. All those points are a record in that data file. And all of those points contain an XY, but all of those points are associated with a supply line, or a gathering line, or whatever we're collecting. So to get information for that line, I have to take those vertical points, and I have to pivot those to be horizontal. So that's what I'm doing here, is I'm taking that data that's in that JXL, and I'm basically pivoting that 90 degrees, so all of those points can now be reported horizontally, and I can say this line 1 has these points, these are the coordinates for it, and then I'm going to start crunching numbers based on those points. So these were different attributes we had for the valves that we were capturing. And I can take those, and for that line, I can now count the number of riser valves. I can count the number of X pipes, of challenge points, right? So I can start to produce metrics based on how that collection went, not only for the field guys to say, I'm done, here's my start, here's my stop, but we can start to quantify the quality of that data and evaluating the types of points they were capturing. Here's an example of just filtering our data. All right. Filtering our data in a way that we need to analyze. So here's some border fence values for border control. These are different types of attributes. And I'm taking these, and instead of my GIS classifications of what we refer to as program, I'm creating attributes that are a little more user-friendly for my end user. So instead of legacy or PF225, pedestrian fence, 225 program pedestrian fence, that was a initiative 225 miles of fence. And I'm creating those values here so they can be, it just provides a better output for the users on the end. So instead of having to add a field, an attribute table and calculate that, you're doing everything in line here. It's just a time saver. And you'll find that processing it this way overall, as opposed to creating those multiple outputs in ArcGIS, merging them back together, you'll save a bit more time using FME for that process. So the nuts and bolts here, statistics calculator, that's our equivalent to our summary stats table in our toolbox. What we're doing here is we're telling the tool how I want to categorize the data. That's my little red circle up there. So our group by is really telling the tool how you want it to look at my input data and group it together, and then do all these high-level metrics reporting down here. All right, so these are out of the box within the transformer of FME. This is what it's going to calculate for you by default. It's going to give you, if it's numeric, it'll give you the min, max, obviously the count. Count is how many features are coming into it. It's if you want a total count of, say you had 35 points you were evaluating, your total count is going to return 35. That's how many points it's considering for these metrics. There's also some other functions in FME that give you a little more expanded capabilities for calculating metrics. So these ones are out of the box over here. Your means, your averages, your range. If you want to do any kind of arithmetic expression to calculate a value, I don't think it says it do average. It does mean. So if you wanted to come up with an average that's a divisor of something else, you could create an arithmetic expression in here that takes into account all those attributes and writes it out to its own attribute here. And then again, that's part of your output. That's something that you're going to give back to the customer that just saves them from having to calculate that same thing in Excel or whatever they're using on their end. That middle bullet there, if you're not familiar with how the stats calculator works in FME, there's a couple different outputs on this. I don't have a picture of it, but the stats calculator, it has 3 output ports on the transformer. There's a sum, there's a cumulative, and there's something else. Each port will basically, one will have all your features coming in and spit them out the other side with all of these attributes appended. The other one will take all your input features and then spit out one record, which is a cumulative report of everything that's read, and I forget what the other one is. But I typically use for what you're doing when you're using the group by, you're going to get one feature for every group by that it considers. So if you read in 500 features and your group by settings report 25 cumulative unique combinations, you're going to get 25 output with all those values. So here's an example of the output, like I was talking about. Here's my line, right? This is our collection. So these were all 98 valves, total on there anywhere, but if you can imagine in that Trimble file, that JXL, this one line had 98 records vertically, and I took those, we spun them on their side, and now we're reporting metrics based on that line. So I can calculate the footage, the number of valves there, whatever these represent. Just do what I'm told. Yeah. And then just the different types of outputs here. This is another one where I'm reporting for Southwest border stuff, just showing an example of this is an Excel writer, and they give you some capabilities to actually format some of the rows that you have available in Excel. So you're not just creating an output, you have some functionality there to control what it looks like. So in that example, I just colored those two because those are the two, being able to access the TI is of importance to them. So whether it's environmentally cleared and real estate cleared, I just highlighted those columns. And then, of course, here's another one. This is just a post FME pivot table in Excel. So I put all this stuff out there in Excel, generated the pivot table using Excel. And again, it's saving you that step of taking all those independent attribute tables, merging them together, and then having to work with them. Right, so this is just, it took all this, so these are all different feature classes I have in the input geodatabase. Obviously changed the names. There's no chicken wire fence along the border, in case you're wondering. And it's just creating that one Excel output. Everything's in line. Your output folder, all it's going to have is that. And if you want, you can add a geodatabase. So this is my metrics report. It's all my nuts and bolts is over there. I have 2 different outputs here based on the government requirements. This is basically all of their TI, and this is basically the TI that they're maintaining or repairing if it gets broke. So if they say, where are the 15 boat ramps in Del Rio? I can say, well, I can pull up my spatial feature class that I created at the same time, and then I can generate a map of those 15 boat ramps. So it's just the power of FME giving you the ability to create multiple outputs at one time in one workspace. Obviously being able to write anything that FME supports, which GIS is a big one and helps us a lot. But that non-spatial component, those tabular reports that people depend on for money, for reporting progress, those things are available to you in FME using those formats. Questions? Yes.
Are you using FME server?
I have used it in the past. I've used that for QC before. The project that was supporting that has retired, so we don't maintain that license anymore. But QC with FME server is very popular. We were using it in the capacity that we actually had a web service set up in our ArcGIS desktop application that we hosted on kind of like a cloud internally. Our users were on ArcMap, they click on a button, they kicked off the web service, and it sent their data from that ArcMap session into our FME server to run the QC on it. So I was ingesting their version, it was a versioned SDE. I was ingesting their version, doing all those QC checks on it, and then in their output folder, I would spit out that text file in a geodatabase. So QC is very popular with that, with metrics. Probably the same kind of process if you wanted to. You upload your data and it crunches the numbers.
How about the raster capabilities of FME? Have you worked with it?
I've done a little bit of raster processing in FME, not a lot. The rasters that I was working with, the processing was it was a little intensive. And I found, and what they'll tell you, FME, they're not trying to replace Esri. So anything that I do, even in my metrics meshing, when I'll take everything, I'm going to focus, I know we're pipeline people, I'm going to focus on board because that's where I'm at day to day. But I'll take the, the counties, the border patrol zones, the real estate interest, and just throw all those together. I'll do that in ArcGIS because ArcGIS is going to work with the tolerances a little bit better, whereas FME is very literal in coordinates. So I'll get a lot of slivers if I use FME, and it creates bad numbers. Same kind of thing with rasters is what I found. I'll process that in ArcGIS. Do you have a question?
Well, I was just thinking with with FME server, it seems like you run a lot of this stuff like on demand as people request or anything. I mean, with FME server, it can do email listening or folder listening for requests or anything like that.
Absolutely, yeah. FME server can tie into services if you have something where people are uploading data and you can ping it, let it know something's there. We haven't used it to that extent because everything we used it for was internal, and this was FME server 2008, so it was years ago. But yeah, FME servers definitely got some, and they have the cloud now too. They have the FME cloud, which is your server hosting capability. You don't have to worry about it. Anything else? Okay, thank you.
Thank you.